Alright guys, welcome back to this video, and in today's video we are going to look at loops in Rust. And so please, if you like the video, you find it interesting, leave a like, leave a comment, and subscribe to the channel. So in Rust, we can repeat things or iterate things, or perform repeating tasks or repeat blocks of code with three constructs. And those constructs are, we have the loop that we are going to look at, a while, and a for. All these are loops, but there is specifically this syntax for syntactic construct called loop, and it performs differently from while loop and a for loop. So without much ado, let's look at a loop and what it is. So head over to your VS Code and create your main file. You can name it anything. Created a main function as the entry point of our Rust code. I can minimize this now. Okay, we are talking about a loop. Let's see its syntax, but first let's declare a variable. It's a mutable variable, meaning this variable is changing. And well, it has to, because as the loop continues, the variable is getting updated in either reducing or increasing. So we create a mutable variable x, and we assign it something like maybe 1000. So the loop is created by the word itself, loop, as a keyword or macro, and then we create curly braces, and then we define whatever we want to create inside the loop. We are going to combine an if statement. We've looked at conditionals in Rust, and if x is less than 0, before I go any further, I need to talk about these two keywords. In the three constructs I have talked about, the loop, the while, and for. In all of them, we have the usual continue and break statements or break keywords. Just like the way you hear them. Continue and break. So these keywords, what's this? These keywords give us a lot of power, that they allow you to skip or and break out of a loop. And yeah, and we are going to see how useful that is. And for now, what we need to know is that the loop is this loop that we are writing. It could be compared to a while loop in C or C++. But let's see how it is constructed here. And we are going to use the help of continue and break. So if x is less than 0, and at this level we should be familiar with if statements in Rust. So if x is less than 0, that means it has reduced from this 1000. We want to break out of the loop. That's what it means. But before it is that, we want to perform something. So this condition can only be true if x has reached a level of 0. In other words, we want to keep reducing x by 1. Okay? There's a better way of writing this syntactically. We can put a minus equaling to 1. Yeah, it's still the same thing. It's just a syntactic sugar. Okay, so x minus 1, we are literally subtracting 1 in every iteration. And that means we are updating x. That's why it has to be mutable. But we need to print out something maybe. What can we print out? So we can print out something just to see what's happening. We can print out those values, but they're going to be quite many. But either way, so more runs to go. And we will pass the value x that is getting updated. So saving this and calling your terminal, opening your terminal. We write Rust compiler, we call it with main, we run, We run the created binary, and that's what we are getting. So we are literally printing from 1000 to 0. Don't know how well, but all you can see is that we are printing from 1000 to 0, and until we get to 0, that's when we break out of the loop. When x, meaning that as we keep on reducing, when x becomes goes below 0, that's when this happens, and that can only happen when x is -1. Okay, we've seen that we've used the basic or a simplest form of a loop, but we can make it more interesting and have this loop more interesting. That in Rust we can put names onto the loop and name them, and this should be possible because what if we have nested loops or loops inside each other? For example, if we have another loop, so that means if we want to differentiate these loops, it's better that these loops have names, and we can do that in Rust. So that is easier, that we can easily break out of them. And the best way to demonstrate that, let's write a function here and see how we can put names onto loop. So we create a function, and I'm going to call it lazy substitution. Lazy sub. Yeah, we are all lazy. So it takes 2 arguments, both are integer 32s, i32. So that means even the return type should be an integer 32. Okay, and basically what we demonstrate here, don't mind about the complexity we are bringing onto table, but what we want to demonstrate is we can actually give names to our loops. Okay, so we create a mutable variable and we call it a result equaling to 0. And when we are declaring names to loops, first of all, we write the loop. We put curly braces, but to name the loop, this is what we do. We put colons so far there, and for the name we put is that an apostrophe? I don't know how you call that. Apostrophe, quote, single quote. I don't think it's a single quote, but yeah, we put that, and we name this loop. Let's call it increment. So that's the loop name, and this is the syntax that we are using to give a name to the loop. So what do we want to do in this loop? Basically, we want to subtract these 2 values. When you have 2 values, get the subtraction. And we know this is very simple, but actually this is not a lazy substitution, but it's a silly substitution because you can easily just subtract 2 numbers. But we want to demonstrate that. So we declare an inside variable here, mute decrement variable equaling to b. Okay, and then we create another loop which we call decrement. So we have nested loops now, and this is a loop 2, and we want to break out of the increment loop, the first one. Okay, and we are going to explain this this loop and what actually happens. So that I'm just breaking out of the loop. No, that's too early. So we have the decrement loop, and we are saying if the decrement variable equals or is equivalent to 0, just break out of the increment loop. Okay, otherwise, what do you want to do? We want to decrease the result variable, which is minus, okay, minus equaling to 1. Okay, I've told you that this is the same as result equaling to result minus 1, but syntactically this is sweet. Okay, then we want to also decrement the variable, and we are going to see what is really happening here, equaling to 1. So we are also decrementing this variable, and we are seeing it starts, we only break out of the loop if this variable decreases to 0. So here we are decreasing it, and remember it is equaling to b. So that means it starts high and it keeps getting to 0 until it is 0, then we stop. But we are going to deeply explain what is going on. So out of the I messed up something here. Actually, yes. I will have to do this. I must have another if statement. If this result that I declared is equaling to A, what do I want to do? That's when I want to do everything here. Sorry about that, guys, but I hope you can still follow. So I have, after creating the first loop, I have an if statement, and all I'm checking is if the result, which is 0 now, equals A. Don't expect this to work, because at the start the result is 0 and A is not 0, because unless you've passed a 0, which is another thing. So we declare a decl variable b, and then decrement. We create another loop, decrement, and we create the if statement. If the decrement reduces to 0, get out. Otherwise, keep reducing the decrement and keep reducing the result. So we get out of this main inside if statement and the loop, and we come to the outside if statement. And all we want is to find a condition in case this result does not equal to A. What do you want to do? You want to be incrementing the result, okay, by 1. This is a complicated way of wanting to subtract two numbers. At the end of the day, return the result. Okay. Now, what does this function really doing? Maybe we need to let's first pass the variables here. So if we let A to equal to 10, this is automatic type conversion, or else we will get that those are integers, and this is 4. If you want, you can say this is I32, but it's not necessary. Okay, so A is 10 and B is 4, and we want to get the result. Let the result equal to the lazy substitution, where we are passing A and B, and then we are printing. Basically, we want to see what is happening. So A minus B is what? Is the result. So we have A, B, and the result. So let's see. Our A is 10. We begin from here. A is 10, if in this case, and B is 4, I think. Yes. So meaning that initially we have the result, which is 0, and A is 10, and when we create this first loop, the loop is saying if the result equals A, definitely this can't happen because the result initially is 0 and A is 10. So nothing happens here. So we come to the end of the loop, which is the else block here, and we keep incrementing the result by 1. So when the result reaches 1, still doesn't equal to A. So until the result equals A, which is 10. So when the result equals 10, then that means we come here. We create a new variable, mutable, equals to B. What is B? B is 4. So we enter the decrement loop. If the decrement or decl variable equals 0, but it's not 0 because it is equaling to B and B is 4, meaning that even this block skips and we come to this. So that means now we start reducing the result again. Okay, so the result starts reducing by 1, and the decrement also starts reducing by 1. So that means at a time, the decrement is going to become 0, and the result is going to become something. But which one collapses first? What we are looking at is if this one reaches there first, just get out of the loop. So the result is decreasing and this one is decreasing. So until this one reaches there first, that's when we get out of the loop. And if you can test on 10, when the decrement is 4 and the result equals 10, so in the first run, the result will equal to 9 and the decrement will equal to 3. The second, the result will equal to 8 and the decrement will equal to 2. In the next one, result will equal to 7, the decrement will equal to 1. In the fourth, I think, the result will equal to 6 and the decrement will equal to 0. So that means it stops there and we break out of that, meaning that the final result that gets returned will be 6. That's if your values, your arguments are 10 and 4. Okay, so the whole purpose of this is to demonstrate giving names to the loop. That's the whole point. And I think we've demonstrated that. So we can run this code and see what we get. Okay, let's increase the screen here. Okay, we are getting a warning. Don't mind about it. Yes, and we are saying 10 minus 4 is 6. So that's one of the ways of showing the power of loops and naming them. And yeah, so thanks guys for watching. Please leave a like, leave a comment, and subscribe to the channel. Bye bye. See you in the next one.